Alright, so a lot of people have been asking us, how do we power our lights for our LEDs? Well, the short answer is a lot of battery packs. Each component has 2 lithium-ion batteries plus a rechargeable 1.2 nickel metal hydroxide battery in order to provide 9 volts for a 12-volt system that is potentially dimmable, which results in a battery life of roughly about 4 hours per charge. But take that with a grain of salt. There's going to be a lot of different variances on how you use batteries. And this is how. Alright, so first thing to know is that the batteries we are talking about are commonly found as AA format. Now, there's a difference between format and type. Type means that what the battery is made out of. Format is the shape of the battery. So when you say D-cell battery, you're talking about a different shape of battery from a AA, a AAA, a quad A. Yes, those exist. I know. It's crazy. And there are tons and tons of different types of batteries. You have your classic alkalines, you have your lithium-ion batteries, you have nickel metal hydroxide, nickel cadmium, lead acid. I mean, I heard something about lemon juice. I don't know. When we have batteries of a similar format but a different type, we're talking about very different things here. When you say a AA battery, you could potentially say an alkaline AA battery, which is a 1.5. Actually, you know what? Let me go and draw this out for you. So you've got one version of a battery that is only 1.5 volts. You have another one that's 1.2 volts, and then you have another one that is 3.7 volts. Now, all these batteries actually look very, very similar if you try to put them side by side. I mean, I've got right here one battery that has a 2.5, another battery that has a 3.7, and your classic AA alkaline batteries from the dollar store at 1.5. Now, taking a look at all three of those, it's hard to tell what the difference is unless you actually read the labels. This nickel metal hydroxide battery only carries a charge of 2,100 milliamp hours, whilst this Trustfire, which is 3.7 lithium ion, carries 900 milliamp hours. And they don't typically list them on these guys because they are quite easily disposable. They're not, unless you have a rechargeable alkaline, which I have not seen in the longest time. Yeah, I still have them. In fact, hold on. Do I still have it in my pocket? Yes, I do. I have one rechargeable alkaline. And these guys, does it list here? They don't say. They don't say how much charge they hold. But some of you are going to ask, hey, Red, but I thought the 3.7 volt has more power to it because it has more voltage. Well, there's another funny thing about that. Every electronics student will tell you about this one. V is equal to IR. What that means is that depending on your load and how much voltage you have, it also puts out a certain amperage. And you can rearrange this formula to find out any kind of part of your system that you really need, including how much amperage you need to get through a battery, how much volts you need in order for it to operate at, or whatever resistance. Algebra. Very simple math. But the formula for power is actually V times I is equal to your power, which is in watts, which is also the same thing when you see in milliamperes per hour. This is the part you see on your battery quite often. So judging by this, your milliamp hours and your voltage are not, they kind of do have some correlation. But what's the big part about how to tell how much power you need is this guy. A lot of people are going to say, yeah, okay, you'll have more lights, of course it's going to take more power just because there's more parts to energize due to, so the current demand is going to be much higher. Yes, of course. But here's a lot of things that people don't realize. One, you can overvolt something very easily. You can undervolt something just as easily. But you cannot overcurrent a pre-made system, especially if it's been designed properly. Your system will only draw how much it needs. So let's say I have my laptop. Now, if I have this power supply that puts out 2 amps, and I have my laptop running at 1.7 amps, this will work. It's only because this is greater than this. If it's equal to, it could still work, but you'd be running a risk of it starting to heat up a little bit more. If it is less than 1.7 amps, then you're going to start to have a lot of problems with the power supply essentially catching fire. Do not do this. So how does that relate to doing electronics in the suit? Well, of course, lights, you've got sometimes a microcontroller, which doesn't take up too much power, but motors will be a big concern. Let's suppose you have, say, a power drill. So I have an 8-cell AA battery pack, which is 12 volts. And let's suppose we stick them inside of this guy, Blastoise charger cannon. Alright, with a 12 volt power supply, ideally that should be running a lot faster, shouldn't it? But it's not enough power. Why? It's because the batteries themselves have something called an internal resistance, which means that it limits how much current it can supply. Now, in order to get this guy spinning properly, I need something that can allow for much higher current, which is why I managed to scrounge together something called a lithium polymer battery, which can go a very, very high amount of current for, like, this is only a 7.4 volt battery, which is a 2-cell lithium polymer. Now, with a lithium polymer battery, wrong button. No, with lithium ion battery, big difference. Now, you're wondering, 7.4, 12 volts. Why is there a difference? Yeah, it's because these batteries can't actually put out enough current to power this thing properly, compared to the AA batteries, which only has a maximum output of maybe 2 amps, when this thing exceeds 2 amps. It demands about maybe 10 amps in order to run the motor on this thing. So, if you do have a system that requires more amperages, make sure you have the right battery type.
Brad, your airsoft is showing.
Shut it, Ken, man, you're outdated. So we have voltage, amp hours, and internal resistance. Every type of battery will have their own different internal resistance, so long as you're not running anything that's really needs that much power, you can use just about anything you really want. But how to tell the difference between, but what does the milliamp hours mean? So let's say your battery runs a 900 milliamp hour, all right? That means you can run a system at full load for 900 milliamps, running at it for an hour straight before your battery dies on you. That's what it means. Oh yeah, by the way, lithium-ion batteries, do not run them dead. You will shorten your lifespan of a lithium-ion battery or lithium polymer battery if it runs anywhere below 2.5 volts. So with that being said, you have your lithium ions, you have your alkaline batteries. You can arrange them however you want in order to add all the voltages to be a 12 volt or 9 volt system, however you want your system to be. Or what you could do is you could put 2 packs of 12-volt batteries. Side by side, positive, positive, negative, negative. And you now have double battery power. Means it lasts twice as long. Actually, that's kind of what I did with Blastoise. Fun little note, if you did add one 12-volt power supply and another 12-volt power supply in parallel, you can actually take advantage of this being able to supply maybe 2 amps of power here and 2 amps of power from here to get 4 amps of power. So if you ever really need to, you could potentially do it that way. Mind you, that is, of course, using the right combination of batteries. So yeah, take a look to see what does your system use. If it's just LED strips, just make sure you get the right voltage of LED strip, otherwise it might not light, or you might even blow it up, depending on what your power supply is. Make sure that you are treating each component of your system properly. If you have a motor in your system, do not put it in the same system with your lights. It will blow up your lights like hell. The wind down on a motor will actually generate power back into the system and then cause it to explode due to overcurrent. Just because how generators work is basically the same process of running a motor backwards. Do not put the batteries in backwards. When you are using a motor, please put a fuse in your system so that it doesn't blow up your battery. Do not short circuit your system because that will blow up your battery. Do not douse anything lithium in water. Do not overvolt your system because that will cause it to blow up. Do supply enough current to run your system. That will prevent your system from overheating, or at least power supply. Do not shoot batteries out of air cannon. Do not put trust fire batteries in fire. I would suggest not mixing up the sizes of batteries. It just gets too complicated. And why would you want to have a square 9-volt battery mixed in with your circular batteries in the first place? This doesn't make sense. Unless, of course, the 9-volt battery is with the quad A, because essentially the 9-volt battery is just 6 quad A's put together. Coin batteries do not fit in a vending machine. It just doesn't work. Something I actually have found out is that certain colors of LEDs actually do respond differently to different voltages. For example, bright blue LEDs might not work past 7 volts, and then yellow LEDs might cut out at 6 volts instead. So the yellows might last longer than the blues, or whatever the heck you have. You can give it a shot to see what happens if you try using less batteries at a time. I do not suggest doing this with electronic circuits though, because they require they're very much more delicate in terms of that. Don't do it with the electronics. You can do it with the lights, but not the electronics. But do not overvolt the lights, because that will burn them out. For any other information on any other batteries, a very simple Google search will give you all the information you need. So I hope that helps, and I will hopefully see you in the next video. Post video section.